The views expressed on Science for the People are not necessarily the views of this station, its affiliates, sponsors, or advertisers.
This week on Science for the People, we're talking with three guests about the challenges, repercussions, and ethics of self-driving cars. Hello and welcome to Science for the People. I'm Rochelle Saunders. With me is Professor Stephen Waslander. He is an associate professor in the Department of Mechanical and Mechatronics Engineering and director of the Waterloo Autonomous Vehicles Laboratory at the University of Waterloo. His research interests are in the areas of autonomous aerial and ground vehicles, simultaneous localization and mapping, autonomous driving, nonlinear estimation and control, and multi-vehicle systems. Stephen, welcome to Science for the People.
Thanks for having me.
So I think probably a good place to start is, how does a self-driving car actually see where it's going?
Well, it uses a whole suite of sensors, essentially. So we add laser scanners. That's the large spinning thing you see on the top of the Google car, which gives you a 360-degree point cloud around the vehicle out to as much as 100 meters. It uses radar, which detect vehicles, pedestrians, and can track those objects really well. And it uses vision, of course, which it uses primarily for lane markings and signs and things like that.
So when you say vision, are we thinking like a typical sort of camera?
Exactly right. Yep. So high quality cameras, global shutter, things that, work really well over a large range of lighting conditions. And then, more than one usually.
So how does it detect things like traffic lights and road signs?
So it's looking essentially for well-known patterns, right? This can easily be augmented with maps. So if you know what you're looking for, it's a much easier problem. And this is, in fact, the Google car strategy. It knows exactly where every traffic light is, and so it only needs to determine whether or not the light's red or green. It simply looks when it finds itself in the right position. But without that, you can still simply do object classification or identification. And often we use machine learning techniques in order to extract those kind of information from the environment.
I would assume if the Google self-driving car sort of has a map where it knows where the traffic lights are, if a new sign goes up or new traffic lights go up, I'm assuming that the car also has a way to detect those surprises.
Right. Yeah. So it's reasonably reliant on the maps that they generate in advance. It's a hard thing to be processing all of that input stream to be looking for any possible sign or lane marking or change in the environment. And so they actually, for the most part, rely on knowledge of where the intersections are and what they should be looking for to confirm the driving state and the safe conditions that they can operate in. But it is possible to do these things online. It simply requires more computational resources. And this is one of the big challenges, is there's so many demands on the computation that fitting them all into a car is actually pretty taxing. And so you have to be selective in what you choose to do.
So when we talk about the mapping requirements of something like the Google self-driving car, which you say it has a lot of reliance on mapping, mm-hmm. Is that mapping stored within the car, or is it constantly kind of reaching out to a network to access that information?
So I believe it's all stored within the car. It is a significant amount of data, and there'd be no reason for the current way they're operating the vehicles to pipe it from the cloud. Essentially what they're doing now is they have about 1,000 miles of well-mapped road, and they drive that same 1,000 miles over and over and over. But in the future, of course, the idea is that you could get updates and expand your terrain as you're driving and collect that information from the cloud. So there's no doubt that could be included, but you have to remember this is a significant amount of data, to the point where my servers in my lab get overloaded if we drive for a few hours and try to keep all the data. So it's really an exhausting amount of data to be siphoning.
Yeah, it doesn't sound like we're quite ready yet to have hundreds of thousands of cars and lots of mapping data ready
all
to go.
Publishing to the cloud simultaneously. It'll be exciting. Yeah.
So is there some ability for these vehicles to learn? So if the map changes or if there's construction that they find, is there a way that they kind of keep note of that? Or if they hit it multiple times, do they keep hitting it as something new until the map itself is actually updated?
Yeah, so we do have examples where this has actually been implemented quite nicely. So there's a distinction between entering in a completely new environment where you have no idea what to expect and detecting minor changes in the environment, such as construction cones or a change in the lane markings to allow for, construction in the rightmost lane or something like this. And so this aspect has been achieved. So if you have a good sense for the environment and the map is complete with, buildings and locations of the main components that you're looking for, and then you see some brightly marked, orange traffic cones, that's a simple detectable problem. And so we've seen demonstrations of this working. So that sort of thing is definitely possible. And yes, machine learning certainly helps with that. And it's used also to identify and track individual, like moving objects, so different types of vehicles and pedestrians at an extreme distance. And that's been really successful.
As part of the mapping infrastructure for self-driving cars that would be heavily reliant on this kind of data, would they have information like some of the road rules in place? So for instance, there are some roads where at certain times of day, certain lanes are closed or certain lanes switch between one direction of traffic or another. Is that built into the mapping, I guess?
Yeah, so there's multiple layers in the mapping, essentially. The base layer, which is used essentially to localize the vehicle or determine where it is within the lane, mostly laterally, but also longitudinally, is simply an altitude map or a height map, which is based on basically 11 centimeter grid cells. So there's a height associated with each of those grid cells, and there's a reflectance associated with each of those grid cells, which comes from the laser data. And so the first step is essentially to just match to that black and white elevated 3D map of the environment to figure out where you are. Then on top of that, there's an understanding of the structure of the roadways that are at that location in the map. And so you can think of this as Google Maps itself on steroids, where it's no longer just do I want to turn left at the corner? It's also how many lanes are there and which lanes are available for me to execute those maneuvers. And so basically, once you know where you are on the map and you know where the vehicles are around you, you can then determine which of the safe maneuvers that are currently allowed in your road position you should select in order to progress as best you can.
It's interesting when you start thinking about questions for self-driving cars. I think about ways that I drive myself places and the things that I have to think about. For example, I recently moved to the Toronto area in the last couple of years, and one of the things I've noticed is driving on some of the busier highways in the Toronto area, I find that when you don't know the roadways, sometimes you don't get a lot of time to merge off or merge on, and then you find yourself crossing multiple lanes of traffic very, very quickly. And I just am sort of trying to think through how a self-driving car and how far in advance they would need to kind of know that in order to go through, or maybe they would do it better than I would.
Yeah, we Toronto drivers are not a patient bunch, are we? No, it's basically the idea would be that the car would be far less blind, right? When you're trying to find your way on a roadway, you're trying to simultaneously drive the car and read signs and determine from eyesight alone what the options are for you for navigating through an environment. You can imagine that that's a unnecessary starting point for an autonomous vehicle. You should simply be able to preload all of the maps up to that granularity we were just talking about, and make sure that your route is entirely planned from point A to point B down to the lane level decision making before you even start doing any of the driving. And so they can predict far in advance. Now, that doesn't mean there aren't still going to be bottlenecks and a lot of traffic that makes maneuvers challenging. And in fact, there's some beautiful stories around some of the self-driving cars getting stuck at intersections because they weren't persistent enough. They didn't, aggressively pull out into the intersection as a human would. And so humans simply bypassed them. And, they were properly following the rules of the road and therefore never got to proceed.
It's interesting to me to think that we need to perhaps program our self-driving cars to be more aggressive. Yeah.
So, or at least to signal to humans what their intent is. And so that was a whole level of inter-vehicle communication that wasn't immediately obvious to the designers in the beginning.
Right, because I guess we as human drivers do possibly and probably sometimes unconsciously signal our intentions to other cars, even if we can't verbally communicate, by doing things like I'm thinking at a four-way stop where you sort of announce that it's your turn by kind of rolling forward a little bit before you go.
Exactly, or nudging it over as you're trying to merge into a lane on the highway, same thing.
So knowing that self-driving cars, at least right now, have to exist in a space where drivers are used to that kind of signaling, are we building that into these cars?
They have to, yeah, or else they do absolutely get stuck at intersections and have very difficult time merging in high traffic volumes. And so it's there's a lot to the challenge. It's sort of, there's one of the questions that often gets asked is how human should we make our self-driving cars? And, my sense is that you need to do the signaling. You need to indicate to the drivers around you what it is your intent is. But beyond that, you can be a polite and courteous driver. I think that's there's a nice intermediate point there where both are possible.
So there's obviously a lot of values of having a self-driving car reliant on very detailed, complex mapping that it can sort of knows where it's going and what's around it and rely on that. But what happens when it goes somewhere new? When it gets driven around in a detour or when something new and unexpected happens? How does it do or deal with that type of challenge? So I'm thinking of a detour on a roadway that maybe it's never seen before.
Right. So the challenge there is really in processing the new raw sensor data and defining those mapping tools that are available in the pre-driven environment. So getting to that same level of understanding of the environment in real time on board the vehicle. And so you can almost think of it as we've taken a bit of a shortcut in the beginning of developing these self-driving vehicles where we allow ourselves to use pre-existing knowledge so that we can really, execute the necessary decision-making processes in real time and easily extract vehicles and pedestrians from the known environment that's more static, right? And so to get it to that next level where you also generate this detailed map knowledge and track your own motion through that environment without real understanding, this is a problem that has fascinated roboticists for a long time at much lower speeds and in much less complex environments. So we have many different algorithms that allow us to build maps and track our own motion through those maps as we're building them. This area is called simultaneous localization and mapping. So you do both the estimation of your own motion and the construction of a map as you move through the environment. And to get that stuff to run at the scale and with the quality and reliability that you need in autonomous driving is a big challenge, but it's an exciting one that a lot of researchers are chasing after.
It's so interesting when you start really talking about the complexities here to think that people and animals just do this really without thinking about it. Gauge how fast we're going, gauge how fast other things or people are going, and we don't smash into each other.
Not that often. No, absolutely.
I guess sometimes it happens.
To me, what makes it possible for humans to do this is the years of training we've had in understanding the world we live in. So when you spot a car coming, and it's veering off into your lane a little bit, you already have a model for what a driver would do and whether or not they react. You're going to do something like flash your headlights at them, or you're going to, slow down and pull over to try to get out of the way. You have a sense for what all of the strange anomalies are and what an odd behavior might be. So you detect those things very quickly, and everything that that's being executed or being that's operating as expected, you simply discard. You barely waste cycles on a car going in the opposite direction, 5 inches from you at 50 kilometers an hour because you're in your own neighborhood and they'll just pass you. And so that's that simplification or that ability to immediately assess and understand what the common behaviors are and to use that for perception and understanding. That's what we're trying to achieve on these autonomous vehicles. But for them, what they see is a bunch of colors, a bunch of points, and it all has to get processed and interpreted into a model and a representation of the environment.
So how do self-driving cars do on adverse road conditions? I mean, as people, we have to drive in all types of different conditions and weather types. Rain, snow, maybe there's ice on the road, fog. Those are some of the things that can be in various ways and in various levels complex or difficult for people to navigate. So how does a self-driving car deal with things like changing road conditions?
So it has a lot of adverse effects. There's multiple ways in which weather conditions can deteriorate the abilities of autonomous vehicles. The first is directly in the perception. So snow or rain actually blurs the image data that you collect with the cameras. It causes a significant amount of speckling in the laser scan data, so you get a lot of noisy points off of the precipitation, and it can accumulate on the ground, especially especially in Canada or in the northern climates, and obscure lane markings, for example, making those kind of lane detection algorithms a big question mark. So very quickly you can lose your ability to perceive the motion and the important elements of driving to the same quality that you can do in pristine conditions. The other big issue is, of course, that the roadways are more treacherous and slippery, and so this is a big challenge for the control side and the planning side. So predicting or estimating the road conditions, how much friction, how much force you can apply to the tires before you'll start to slip, that's another interesting and challenging problem. And so you can build up estimates as you're moving along, but those conditions can change very quickly, especially with hard to detect things such as black ice.
Yeah, I mean, when we drive, especially on things like ice and snow, you sort of learn a little bit about the conditions. As you slip a little bit, you learn, okay, well, maybe I have to take a little bit more time to slow down or drive a little bit slower. Is that something we need to build into self-driving cars? That
Absolutely.
Kind of learning?
Yep, and there's a lot of work on this already. In fact, the stability and traction control systems already prevalent in most vehicles today have the ability to estimate on the fly the kind of traction they're getting and then transfer torque to the other wheels, right, to try to maintain control of the vehicle. And so you see that whole field evolving quite nicely, and it's an easy win for the vehicle manufacturers. They love that stuff. But on the perception side, it's a new challenge for us, really. Most robotics applications have not operated in these adverse conditions, and it's a real challenge to get the same kind of quality out of the sensor data.
You mentioned as well problems detecting lanes, and anybody who's ever spent a lot of time driving in snow, especially fresh snow, knows this pain. There's fresh snow on the ground. You can't see where any of the lanes are. If there's a lot of heavy snow, quite oftentimes the cars generate almost new lanes that are kind of shifted over a little bit. They sometimes get smaller. They sometimes get bigger. I've been in situations where a 3-lane roadway went down to 2 lanes just by virtue of where people were driving and how much snow had been sort of shoveled over onto the side. So that seems like it would present quite a challenge to self-driving cars.
Yeah, and so the logical approach would be to try to detect those new lanes, right? Essentially what happens is where the wheels have passed, you get better access to the asphalt and therefore less or more traction. And so that's really where you want to be. You want to be following in the tracks of the vehicles in front of you. And so this is, I think there's a natural solution there that it's just something that nobody's demonstrated yet. So you'd have to detect tracking the vehicle in front of you and then confirm that that's a safe maneuver, sort of allow the autonomous vehicle to violate the lane markings that should exist underneath the snow, but nobody can see. And then execute the maneuver on the better asphalt.
And if there's, let's say, a fresh snow and your self-driving car is the very first car on the roadway, there's sort of no one to follow, no existing tracks. Is that a more difficult or perhaps maybe an easier problem?
Well, then you fall back on drivability. So, the whole autonomous driving craze or wave, I guess, kicked off with this DARPA Grand Challenge back in 2005, and they drove essentially 200 miles across the desert on dirt tracks and open, dried up lake beds. And literally the challenge there was identifying where it was safe to put your wheels. And so that's simply an assessment of the surface in front of you, and simultaneously an assessment of the conditions and how quickly you can accelerate or decelerate. And from there, it's you just plan your route essentially. And so it helps if you have an inertial measurement, so GPS integrated with inertial, so the same stuff that you use to define orientation in your phone, because then you can track your motion relative to the known location of the map of the roadway. And try to maintain the vehicle on a drivable surface, so on the roadway somewhere. But from there, you're essentially building new tracks on stuff that's flat.
So, as someone who works on these projects and has some expertise in this area, what are some of the other most difficult challenges for self-driving cars that we haven't talked about?
Well, on the flip side of this safety issue of trying to get the vehicle to be reliable enough to compete with humans in terms of safety performance is the challenge of trying to prove in advance that the vehicles really are that safe. So you can imagine from a certification perspective, it would be wonderful to be able to say before we deploy these vehicles to the public, yes, we can guarantee they'll be as safe or safer than a human driver. And this is really a challenge of going through every possible outcome, every possible failure mode that could occur within the autonomous driving space, and defining the probabilities of these kinds of failures and the severity of the failure that would result. And this is an undertaking that we've started actually at the University of Waterloo with one of my collaborators.
It does seem like a really difficult question because in a world, in sort of many other situations, you just put it on the road and see what would happen. But obviously that's not a good choice in this case.
Absolutely, yeah. And so the other aspect that'll be interesting is trying to drive the costs down on these systems. So you can imagine currently the hardware is at very small volumes, so it's hard to come up with an actual number for the cost to deploy this to the public. But we're trying to buy our own full-scale self-driving vehicle, and it's going to cost us $300,000. So I guess the road to market is going to be interesting. So just the sensors alone are going to add $10,000 to $15,000 to the cost of the vehicle, and then on top of that, you have all of the algorithm development, all of the computational platforms required to make sure that this stuff works. So it'll be interesting to see. It'll obviously start at the high end of the market. We already see all of the features showing up in Teslas and Mercedes S-Class vehicles, and they'll only slowly trickle down to the average consumer.
Steve, thank you so much. That was really great, and I look forward to hearing more about what's coming out of your guys' lab.
Wonderful. Thanks for having me.
And if you want to know more about Stephen Waslander, his research, or the Waterloo Autonomous Vehicles Laboratory, we've got links to get you started on our website, scienceforthepeople.ca. Next up, Desiree Schell will speak with author Martin Ford about the implications self-driving cars have on employment and work. Stay tuned.
Science for the People is a weekly radio show and podcast that explores everyday life from a scientific perspective. We are a member of the Skepchick Network, a collection of blogs, podcasts, and video content focusing on science and critical thinking. To find out where Science for the People airs near you, or to listen to past episodes, check out our website at scienceforthepeople.ca. You'll also find links to support us at Patreon, to connect with us on Facebook and Twitter, and to subscribe to the podcast in iTunes. And now, back to the show.
Welcome back to Science for the People. I'm Desiree Schell, and I'm here with Martin Ford, author of The Lights in the Tunnel, Automation, Accelerating Technology, and the Economy of the Future, and the New York Times bestseller, Rise of the Robots, Technology and the Threat of a Jobless Future. Good to have you here, sir.
Thank you. Good to have you.
So self-driving car technology is moving extremely quickly. By many accounts, we will start to see autonomous cars in showrooms by 2020, and the Institute of Electrical and Electronics Engineers has estimated that up to 75% of all vehicles will be autonomous by 2040. Now, as with all discussion of the future of robotics, I am equal parts excited and concerned, but in this case, I'm particularly concerned about the economic impacts of driverless cars. So, Martin, I would like to do a bit of speculating about how this might all play out. Does that sound good?
Sure. You're right. I mean, it's definitely potentially a staggering impact when you think about the number of people that basically get their livelihood from driving cars. I mean, it's, between the United States and Canada, it's millions of people for sure. I think that in the U.S., actually driving vehicles is the most common occupation for men without a college degree. So, I mean, that's the level of impact that you're talking about. Now, of course, people will point out that driverless cars potentially bring many benefits. We're going to have less accidents probably on highways, less people hurt and killed and so forth, and that's all great. But we can't escape the fact that there's going to be a huge impact on employment, and many of the people that do that for a living are not going to have an easy time transitioning to other things, even if those opportunities exist. Beyond just the impact on employment, people driving cars, there's also an even bigger impact than that. I mean, you think about all of the individual repair shops, all of the car dealers, the insurance agents. All of these things exist because we all own our own cars, and yet most people who have looked at the phenomenon of driverless cars think that, at least in urban areas, it's going to eventually mean that people don't own their cars anymore, that in fact driverless cars will become a shared resource, and you'll simply call up a driverless car the way you call up for an Uber driver now, and the car will arrive. So if that happens, that's a complete paradigm shift. I mean, that completely upends the way just a huge part of our economy now works. So it's going to be a potentially staggering impact.
Well, let's break this down. Let's talk about the potentially horrible things first, and we'll talk about the potentially good things later. And I do just want to put some numbers down for people. One of the Gizmodo articles on this topic that I looked at, they crunched the numbers in the U.S. specifically, and it looks like self-driving cars could leave the following folks jobless: 180,000 taxi drivers, 160,000 Uber drivers, 500,000 school bus drivers, and 160,000 transit bus drivers. That is 1 million jobs, not even mentioning the peripherally related jobs that you mentioned. So let's talk about Uber for a second, because I find this interesting. Aren't they actually developing their own self-driving cars?
That's right. They've invested in a research facility to do that, and of course that completely upends all the assumptions about Uber, the fact that it's creating all of these on-demand jobs in the so-called gig economy and everything. Those jobs will be there for a while, but clearly the company is looking forward to a point when all those drivers are going to disappear and it's just going to be self-driving cars. So, that has real implications for what people assume about the future, I think.
Well, isn't that kind of unusual itself? Doesn't most disruptive technology come from outside the industry that it's disrupting? Because Uber is aggressively creating jobs right now so that it can effectively wipe them out later?
That's right. I mean, but Uber is, of course, outside the traditional industry already. The interesting thing about self-driving cars is that virtually everyone is now working on it. It started at Google, which is maybe not the place you would expect it to happen. It then migrated to nearly every automotive manufacturer has got some degree of research into self-driving cars. Even Apple reportedly is working on a self-driving car. So, I mean, there are initiatives underway all over the place, and it's unclear, where the real disruption is going to come from. But I do think that the fact that there are so many different entities working on it is suggestive that it is definitely going to happen.
Well, how about truck drivers? I don't think we talk about that enough. Long and short haul truck drivers, they'd be affected as well.
Potentially, yes. I think that, some of this stuff, I think that some of the estimates are a bit aggressive. This, in many ways, this may move slower than we expect, not necessarily because of the technology, but because of social acceptance and regulation and so forth. There are technical challenges for self-driving cars that remain. For example, dealing with snow and weather and dealing with road construction and things like this are real challenges that have not yet been overcome. So, those are real challenges. In the specific area of trucks, you're talking about vehicles that have just massive destructive potential. And I think that there's an element of social acceptance there, that people are not going to be comfortable with these enormous heavy trucks driving around with no one in control. There are also, again, issues in things like road construction and so forth. So I think that it will probably happen a bit slower there. I think that for the foreseeable future, in the case of heavy trucks, you're going to have someone in that in that driver's seat, even if they're not actually driving the truck. Even if the truck is in fact driving itself, there's going to be a person there to assume ultimate responsibility, I think.
Okay, but since we're engaged in rampant speculation at this point, I'm just thinking if public acceptance does increase, we would see things like that's the thing about truckers, is that they sleep and they eat because they're human, and therefore they stop at all the diners and gas stations and motels along the way. So if driverless trucks actually started if people became interested in them, we could see all of those peripherally related industries, and specifically in small towns along the side of highways, those could potentially disappear.
Sure, yeah. All of these things, when you begin to wrap your mind around the peripheral type jobs that could be impacted, it's kind of mind-blowing. Everything is connected. And when you take, automobiles and vehicles in general and driving and all of the stuff that's associated with that is just a huge part of our economy. It's become, in starting in the 20th century, it's become an enormous driver of our economy, and also one of the most important things that really has sustained our middle class is all of those jobs associated with the automotive industry and driving. So, I mean, once those start to go away, it really upends everything on a very massive scale.
Well, so the typical response to the idea of all these job losses is that there will be reemployment, right, in newer related industries. So what might that look like?
Well, I mean, there's an element of truth to that, and historically that's been true. And you can sort of, you can think of futuristic industries that are likely to exist, things like nanotechnology and synthetic biology and all of this stuff. The question is, are you going to be able to take, the taxi driver and repurpose that purpose into that industry? And for the most part, I suspect that the answer is going to be no, because first of all, those industries probably won't create that many jobs. I mean, we already see that with companies like Google, for example, that become just fantastically profitable and influential, but really don't employ many people at all relative to other industries like the automotive industry. I mean, Google actually employs about something like 4% of the number of people that worked at General Motors when General Motors was at its peak. So right from the beginning, they don't create many jobs. And of course, the kinds of jobs that they create are also quite different. They're not jobs for average people. The jobs at companies like Google are really jobs for exceptional people that have, all kinds of education and very elite capabilities and so forth. And I think that that's likely to sort of be the model going forward. There will be new technologies and new industries and new things created, things that we can't imagine today. But, the jobs that exist at those new organizations and industries are probably going to require very elite capabilities and skill sets, and they're not necessarily going to be accessible to all the people that are now driving vehicles and flipping hamburgers and doing all the work that is likely to be impacted by automation over the next couple of decades.
And we should probably, point out also that while driverless cars would eliminate a lot of the vehicle-related jobs, automation is also increasing in other industries. So any related jobs would be heavily competed for across a number of industries.
That's right. So you can't assume that people are going to lose their taxi driving job and get a job, in the fast food industry, for example, because those jobs are going to automate too. And in fact, even many more skilled jobs, even if people do what we believe they should do, which is, go back to school, get some more training, get some more education, what we're seeing is that very often those more skilled professions are also being impacted.
Right.
Fields like journalism, for example, we now have automated systems that can crank out news stories. A lot of the more routine work that's done by lawyers and paralegals is being impacted. In fact, any kind of job where you're sitting at a computer doing some kind of knowledge-based job, cranking out the same report again and again, all of that is going to be very susceptible. In many cases, it may be easier to automate than, the driving job. I mean, let's face it, building a self-driving car still remains a staggering technical challenge, whereas building an automated system to write reports or do some sort of financial analysis is actually, in many cases, a lot easier. So some of the higher level jobs that require more education may, in many cases, actually be easier to automate than some of the lower skill jobs.
Are there any other potential economic impacts of autonomous cars that I should be obsessing about, perhaps?
Well, I think that the impact of just taking away all those jobs and all the peripheral businesses, as I said, things like repairing cars and insuring cars and selling cars, if all of that eventually kind of erodes, that's just a staggering impact. Beyond that, the more general economic impact that I talk a lot about, not just from self-driving cars, but generally from this process of automation, is that in order to have a thriving economy, you've got to have consumers out there. That means you've got to have people that can buy whatever's being produced. So if people really begin to lose their jobs across the board, or if their incomes are driven down because they're competing, more and more for a shrinking number of jobs, then it's hard to see how the economy is going to thrive, because there aren't going to be enough people out there that can really buy what's being produced. So that's another long-term problem that I think that is likely to become more important going forward.
This is Science for the People, and we're talking about the economic impact of the driverless car with Martin Ford, author of Rise of the Robots, Technology and the Threat of a Jobless Future. Okay, so let's talk about the potential benefits of the self-driving car. What do you see happening there?
Well, from the technical side, the people that advocate driverless cars believe that they will be much safer. We have a staggering number of people killed in automobile accidents across the world every year, and this is largely because, human drivers aren't really all that great, and we make a lot of mistakes. Robotic cars will be a lot better and a lot safer. That's what most people believe. There may be accidents here and there, but certainly overall it's very likely to be much safer, so we'll have a lot fewer fatalities. That's probably the biggest advantage that you can point to. The second is that things may generally be far more efficient. Again, as I mentioned earlier, the model that most people envision is that we're not all going to own our own car and have that car sitting there, idle 95% of the time. Instead, driverless cars would become a shared resource, which means that they'll be on the road all the time. There'll be much higher utilization. They'll be parked a lot less often, and so there'll be less need for parking space in cities. That'll free up a lot of real estate. So things will generally become much more efficient, and it could, of course, also be better for the environment if fewer cars are on the road, and especially if they're electric cars, for example. There are many advantages in terms of efficiency, in terms of the environment, in terms of safety. Although there are a lot of problems associated with driverless cars, I'm certainly not against them. I don't think we should put a stop to them, but I do think we are going to need to adapt to the implications of driverless cars, and one of the biggest things we're going to have to deal with is going to be the threat to all the people that now derive their livelihood in one way or another from the automotive industry and from driving vehicles.
Well, let's actually talk about that. You mentioned that cars may sort of evolve into public resources, but will that actually happen? Because I can't imagine that the automotive industry would want to promote that. That is overall far less cars sold.
That's right. If you look at what the automotive industry is working on in terms of this technology, almost universally what they're doing is sort of a semi-autonomous approach. The idea that there's going to be a driver sitting behind the wheel who's ultimately responsible for the car, but the car may be capable, at least in many instances, of driving itself. And many people looked at that and come to the conclusion that could well be more dangerous. You can see the obvious problems there. We've got problems now with people texting when they're driving. What's going to happen when people begin to really rely on the car to drive itself in some situations, but then suddenly you get into a situation where the person is expected to take control back. How does that work? And many people that have looked at this, and in particular the people that are at Google working on self-driving cars, have come to the conclusion that that's just not workable. So there is sort of a competitive dynamic that's been set up between the Google side, which says let's build cars that really drive themselves, and the automotive manufacturers that are saying, let's do something less than that. And I think it'll be interesting to see how that plays out. But you're right. If we're really going to have fully autonomous cars that are going to be a shared resource in the future, it's very likely that technology is going to come, I think, from outside the automotive industry, because obviously it's going to be quite harmful to the automotive industry. It's not something that they're really going to want to pursue.
Well, and actually even more than that, I was thinking about if people don't own their own cars, will cars still be seen as a status item? Because I don't care what kind of car my cab is, as long as it gets
That's right.
me.
So,
right.
Yeah, so that would potentially be very damaging to, the luxury car brands, because no one will care, right? Now, I think in terms of cars being a shared resource, obviously we're primarily talking about urban areas, cities. Outside of cities, the story may be different, but certainly, that's still a staggering impact on the number of cars that are sold. And, from an environmental standpoint, that would be a great thing, right? There's nothing good about having the world full of cars that for the most part aren't even utilized most of the time. There's definitely a tension there between what's good for the planet and what's good for society, and what's good for the automotive manufacturers. So, we'll have to see how our struggle plays out in the long run, I think.
So I guess my question is, and I think you probably have made yourself clear, will all these potential benefits justify the jobs lost?
I think they will if we can adapt to it. Our challenge is going to be to adapt our systems so that we can leverage all these technologies and get the good side without allowing the negative side, which is the loss of jobs, to undermine our whole economy. But if we don't make that adaptation and we just let it play out and don't do anything, then I think we're going to be potentially running into a lot of trouble, economically and socially.
So now you've said adapt, but adapt how, sir? How do you propose to mitigate this?
What I've suggested in my writing is that eventually we're going to have to look at something perhaps like a guaranteed income, where everyone is going to have access to at least a minimal income, whether they can find a traditional job or not. And that's an idea that's getting some traction already across the world. I mean, in Europe, they were beginning to talk about it. Finland actually is very seriously contemplating moving to a guaranteed income model to replace their existing social safety net. So, I mean, it is a discussion that's kind of developing. There are people in Silicon Valley also talking about it. So I think that eventually, I mean, and I'm thinking probably decades in the future, 10, 20 years from now, this might be an idea that really becomes viable, even though currently it's kind of politically unthinkable.
And so are you saying that we will have to wait until this actually becomes a crisis to take that seriously?
I would hope, on one hand, I would hope not. I would hope that we could plan ahead and see what's coming and adapt smoothly to this. But I think history shows that that's not how things work, that we don't make big shifts in our economic and social model based on future planning. Big changes happen when a crisis happens. So I guess that if I had to bet, I would say that we'll get into some big problems and then eventually we'll make the changes that we need to make.
Well, and as you said, it isn't just the driverless car industry that this is taking place in. It's across the board in many industries. We're seeing increased automation.
That's right. I mean, driverless cars is just one, in my book, it's not even one whole chapter. I mean, this is a really across the board and that's what makes this so dramatic, is that it's everywhere. It's not, I mean, if it were just self-driving cars, then we'd say, hey, all those people are going to find jobs in other industries. But the problem is that's not the case because this is happening everywhere. So that's what really defines the problem, is the fact that it's so broad-based. It's something that's going to scale across the entire economy.
Well, that was super depressing. Thanks very much for being here, Martin.
Okay, thanks for having me.
And that was Martin Ford, author of Rise of the Robots, Technology and the Threat of a Jobless Future. We've linked to him on our site at scienceforthepeople.ca. Stay tuned for Rochelle Saunders and her interview with Jason Millar on the ethical questions raised by self-driving cars.
Every week on Science for the People, we take the latest in scientific progress and relate it to people, our friends, our families, our communities, and our society. And we give researchers, authors, and journalists the time to talk in depth about what matters to them. If you love science but aren't satisfied with sound bites, join us again next week for Science for the People on your local radio station or anytime online at scienceforthepeople.ca.
You're listening to Science for the People. I'm your host, Rochelle Saunders. With me is Jason Millar, a postdoctoral fellow at the University of Ottawa, Faculty of Law, where he researches the ethics and governance of robotics and automation technologies. He teaches philosophy at Carleton University, is the chief ethics analyst at the Open Roboethics Initiative, and is a member of the Foundation for Responsible Robotics Organizing Committee. Jason, welcome to Science for the People.
Hi, thanks for having me.
So I think the best way to start talking about self-driving cars and ethics is to, maybe you could tell us about the tunnel problem, which I think is a good entry point for a lot of listeners.
So in the tunnel problem, I ask people to imagine themselves sitting as the passenger in a driverless car. And the driverless car's driving along a mountain road, a narrow mountain road towards a narrow mountain tunnel. And suddenly in front of the car, there appears a child, and the child stumbles in the road and falls and is effectively blocking the tunnel, the entrance to the tunnel. And of course, in this kind of a situation, the driverless car is going to have to make some sort of a decision. Unfortunately, in this case, it can't brake fast enough to avoid hitting the child. So the choices that it has are to brake hard and continue straight, probably hitting the child and killing the child, or swerving into the tunnel wall, effectively harming or killing the passenger. And I ask people in this situation first to ask themselves, what would you want the car to do in this situation? But the purpose behind the problem is to get at another question that I follow up with typically when I'm talking about this, which is, who should make this decision in the case of the tunnel problem?
So who are the possible players who could make this decision in the case of this problem in a self-driving car?
If we imagine the driverless car in what we would think of as a traditional driving context, where the person in the car is in control of the car and has the ability to, steer the car this way or that, and that really is a good starting point, I think, because it's what most people are going to immediately think about in that situation. Then it really becomes a problem for either the person in the car, or then we can start thinking about the people outside of the car. So in the case of the driverless car, you have the alternative options. I mean, here we have a computer essentially that has to be programmed by someone. So the other people that you can imagine would have to make this decision are the designers of the car. But then there's this third option that we can think about in the context of driverless cars, which are regulators. So we have really three options of thinking about who should be making that type of a decision in the context of driverless cars, at least, if we're imagining these things as we would in a typical driving context today.
So obviously today there are kind of two people in the mix really right now. We have the driver who makes a lot of the decisions in the moment, but there are also some laws that govern things like rules of the road that a government or regulation or regulators kind of put in place. But primarily we think of the ethics of driving your car right now to really be in the driver's control. So this third sort of designer element is something that's a little bit new to us and a little bit new to this problem, correct?
So many of these cases that they'll find themselves in, these what we might call unavoidable crash scenarios, they're going to have to be, the outcome is going to be determined by the programming of the car, right? The way that people are envisioning these cars in the wild, if you want to call it that, when they actually get deployed. If you look at the Google cars, they don't even have a steering wheel in them right now, and certainly that's the model that Google is shooting for. So the vision of these cars is to take the driver as much out of the scenario as possible, and just have people in the car making all of the decisions. So really, the designer starts to feature as a really important player in the ethics of something like the tunnel problem, just because the driver actually doesn't have the physical ability to change the course of the car in that moment. This is going to come down to the programming of the car. Interestingly, though, it's not entirely clear to me anyway that, and this is what I argue in a lot of the work that I do, that the designers are the individuals that we should be looking to make some of these tough moral decisions that we can anticipate are going to come up in driving contexts with driverless cars.
So who, in your opinion, do you think should be in control of most of these really difficult ethical questions?
If we ask ourselves in other contexts, this is the work that I do, I kind of draw from other similar contexts where we have people making tough life and death decisions on behalf of individuals, and namely healthcare. If we look to the healthcare industry, we have a broad literature on how to make decisions that concern particular individuals. So in this case, it's important to notice in the tunnel problem that, first of all, the driver's not at fault for anything. I mean, if you want to just talk about the legality of the situation, I designed the problem specifically to have someone kind of stumbling into the road who shouldn't be there, right? Unfortunately, in this case, it's a child, but the child really should not be there. And legally speaking, there's no obligation for a driver or the car, in this case anyway, to swerve out of the way. So it creates a moral situation where, similar to what we see in healthcare, where you have questions about particular individuals having to make tough decisions about, say, end-of-life decision-making, what kind of treatments they want near the end of their life, and so on and so forth. We tend to default, for very good reasons, I think, to allowing those individuals who are most affected and who we would say have the moral authority to make those decisions, we default to them. So in healthcare, it's the patient, right? In the case of in this driving context with the driverless car, again, if we're kind of modeling things after a typical driving scenario as we understand it, it's the person in the car who seems to have the moral authority in this case. So in the work that I do, I make the argument basically that the tunnel problem points to an interesting ethical situation where the person in the car seems to be the one who has the moral authority to make the decision, especially when you're comparing it to the designers, because the designers making a decision in that case would be would be something like a paternalistic decision, which is problematic for various reasons, ethically speaking. But the interesting problem in the tunnel problem here with asking the driver to make the decision is how could we practically do that, right? So we see this kind of problem with driverless cars where it seems like we might want to point to the driver and say, well, we need to take their concerns into consideration in these tough moral cases. But it's tough to know how to do that in the moment. Practically speaking, it may not and is likely not an option to seek the driver's input in all of these scenarios. I mean, that would be burdensome for designers. It would be burdensome for drivers as well. So that really points to the problem here. We have to ask ourselves, how do we respect these kind of ethical intuitions we have about individuals having the right to make tough moral decisions for themselves? How do we balance that out with the need to program these cars to do something in advance?
It's a really interesting topic, and one of the topics that I've recently read a little bit more about and been thinking more about is the things like emergency situations. So, the whole idea that driverless cars might be programmed to break laws in some specific cases,
right,
which I find really fascinating.
Well, the whole concept of driving laws stops making sense when you start thinking about driverless cars, right? I mean, most of the laws are designed with human drivers in mind, with all our fallibilities and variability between users. It's the fact that you can't easily control the roads that you come up with these vague kind of generic laws that most people have a chance of working with, right? So speeding and controlling a car is just something that we're not great at. We're not professional drivers. So in a driverless car context, you can imagine just opening those rules up entirely and still maintaining the safety factor, right? You can have a car speeding along at high speeds in an emergency situation and confidently guess that all of the other driverless cars are going to pull over and give it room, where you can't do that with people, right? So it's really interesting. I mean, the implications are massive of this kind of technology.
Yeah, because you can definitely force things like you say, if there's one car that's sort of marked as an ambulance in a certain situation or has that sort of like classification of emergency vehicle, you can literally tell all the other vehicles to stop until it's X amount of meters away or X amount of kilometers away. And you won't have sort of people in those cars able to override that kind of stuff. I think some of the possible interesting ideas around like sort of laws feeling more arbitrary when you've got self-driving cars is really interesting and something I hadn't really thought of before. So the idea that if there's no human driver in play, then the average speed of how people get from point A to point B in a car could be potentially much, much faster because you're taking the human element out of it.
Yeah, much faster when it's okay to drive fast, like the road conditions, and much slower when it should be slower and all those things. There are also groups doing work on kind of like the distribution of driving goods, which is another interesting philosophical problem. So it's like, who gets to go faster? Do you pay into that? Like, does that create all sorts of new inequities? You could imagine, Lexus and Tesla and these kind of companies saying, well, these are luxury vehicles and we own, so GM will own the luxury vehicle line and the cheap vehicle line. And they might say to customers, if you buy our luxury vehicle line, then it gets a speed advantage over all of the other vehicles in our line. Or you could buy that as an upgrade, like an option now, right? Like a get there first option, so that at least when you're dealing with other GM cars out there, this car will get you there slightly faster. You'll get priority in turn lanes and things like that over other GM vehicles on the road. Or I mean, you can imagine all sorts of crazy stuff that companies come up with to sort of sell their cars to people.
Yeah, kind of
it bumps up against like public distribution of goods, right? What's the best system in terms of distributing the right to get there faster.
Sort of like a hack the system rather than hack the individual car, where you get an advantage within the system.
Oh, absolutely. Yeah.
There's a lot of interesting questions there.
I mean, because that's, it's an opportunity for people to make money at the expense of, again, like people who don't have that kind of money, and they end up taking a little bit longer to get to their low paying jobs and all this. Like, it's the same kind of inequities that you see right now, right? Like, it's the whole riding the bus versus driving the car debate.
At the end of the day, a user can't make all of these decisions up front. It would just be too burdensome and too time consuming, and would really kind of negate the usefulness of driverless cars in a lot of ways. And so I guess my question is, how important is transparency of the code in place that controls the ethical behavior of these kinds of vehicles?
So I think that's going to emerge as a very important feature of these cars, right? Just like Facebook has to make their privacy settings transparent, their privacy functions transparent, I think in order for people to use the technology, right? Why does Facebook do that? Because, users don't trust the technology that's passing their information around in ways that they don't understand to a certain level, right? This is why the backlash happened with Facebook. So you can imagine the same thing happening with driverless cars, only given that cars are able to crash into things and harm people, I think the problem is amplified. So we're really going to have to think seriously, and designers and manufacturers are going to have to think seriously about how much they value code secrecy, or keeping these things proprietary versus opening it up and making it available for public scrutiny. So that people trust these technologies. And from a public regulatory perspective, if there are these benefits to driverless cars, and there certainly are, right? I mean, driverless cars could have a massive positive benefit to society in all sorts of ways. I mean, you're talking about a reduction in accidents. You're talking about, so you're saving lives. You're reducing healthcare costs in societies. You're probably reducing costs to infrastructure. If you imagine far enough down the road, things like traffic lights go away. You don't have to maintain that infrastructure. You don't have to paint lines on roads. There are all sorts of things that you won't have to do with a system where all the cars are driverless. So there are all sorts of benefits that we can imagine coming out of driverless cars. If we don't get the trust aspect right, if people aren't willing to step into these cars, we're stuck with cars that we have today, which we know are quite harmful, expensive to the system, in terms of both money and lives. So really, it's about getting the balance right between what we have to inform users about, what we have to regulate, in some cases, what users get to make their own decisions about, individual users, versus designers. What kind of problems designers have the moral authority to solve and keep secret? They'll always want to have some advantages in terms of secrecy over their competitors, and what things regulators just have to step in on to smooth the whole design process and make sure that the variability between manufacturers is limited in cases where it needs to be limited for public goods and public value trade-offs and things like that. So really, if we get the transparency question right, it serves to gain in terms of people's trust of the technology. And you want to make sure that people trust technology that is actually trustworthy. So I think that's why we need to focus on that transparency issue and take it seriously.
Jason, thanks so much for your time today. And really interesting topic. And I look forward to getting lost in many more comment threads and conversations about this topic.
Well, thank you. Yeah, it was great talking to you.
If you want to learn more about Jason Millar or his work, we have links up on our website, which you can find at scienceforthepeople.ca. On our website, you can also find all of our previous episodes and links to find us on both Twitter and Facebook, where you can keep up with the Science for the People team. You can also find us on iTunes, on SoundCloud, and now on Google Play, where you can subscribe to get new episodes of the show delivered to your smartphone or other portable device as soon as they are available. Thanks for listening, and we'll see you next time on Science for the People.
Science for the People is produced by Rochelle Saunders and edited by Ryan Bromsgrove. Helen Quivalon is our publishing liaison. We get research help from Josh Whitten. Coordination and additional behind-the-scenes support comes from the enthusiastic Skepchick Network team. Our theme song was written and recorded by Fractal Pattern, and its title is Binary Consequence. Science for the People is listener-supported. You can find us on Patreon, where you can support us with monthly donations in any amount. In return, we regularly post special patron-only extra content and after-show casual conversations with guests. This show is created in partnership with the Skepchick Network, a collection of blogs, podcasts, and video content focusing on the intersection of science, popular culture, politics, and social justice. You can find out more about Skepchick at skepchick.org. The show is hosted by Rochelle Saunders and me, Desiree Schell.